Welcome back. These are practice exercises on sound. And I think today we're going to be doing like how long a guitar string is going to be, and some other kind of I think most of it's about the same thing. Also, I think the last one might be on beats, and we saw from today that that's actually real easy. All right, so let's look at number 10. Melody puts a fret on her guitar string. Okay, so she's pinching her guitar string. It's tied at the bottom, if you know what a guitar string is, and you pinch it, and now you make that a certain length, and you're going to be asked how long the string is if it makes a certain pitch. So its fundamental frequency is 250 hertz. It tells you that in the air, its sound is traveling 350 meters per second. How long is the guitar string from where it's attached at the bottom, at the fret at the bottom, to her hand? Okay. Well, there's actually a formula here, so we're going to see that the length of that string is going to equal how many nodes there are, or I'm sorry, how many antinodes there are, how many humps there are. If you remember that you have a node where it's attached, and then the antinode where it's actually vibrating. So that string is vibrating as one solid back and forth from here's where it normally lives, and then it's back and forth this way. So we've got one antinode times the velocity of the sound, okay, divided by double the frequency. So it's a nice, easy formula. I would have hated to derive this, but I'm glad somebody else did. There's smart people in this world. So put it together. We've got one antinode, okay, since it's top to bottom vibrating as one string. Okay, it's not going in doubles or triples. Okay, we're dividing that by 350 meters per second. That's the speed. Oh, got it wrong. Let me see. Let me back up. I'm not dividing. I'm multiplying that by 350 meters per second. Now I'm dividing it by twice the frequency of that pitch, and twice the frequency is going to be 250. So I have 350 divided by 500, and that's going to be 0.7 meters. So that length of the string from the bottom of the guitar to the top, and remember a meter is about 3 feet, so that's one of the long strings, and her finger's not very far up the fret, is 0.7 meters. Okay. Now, if the second question said, how far and in what direction must the fret be moved to produce a fundamental frequency twice as high? So remember, instead of a 250 hertz pitch, where do I have to put my finger in order to make it a 500 pitch, 500 hertz pitch? Well, what do you think? If this long one vibrates at 250, then 1/2 of that would vibrate at 500. The smaller the string, the higher it's going to vibrate. And so if you want it twice as high, you need to go twice as far down. So it needs to go twice the distance, okay, or 0.35 meters from the bottom. Okay. All right, number 11. The fundamental frequency of a bass violin, so that's a double bass, is 1045 hertz, occurs when the string is 0.9 meters long. Okay, how far from the lower fixed end of the bass violin should you place your fingers to allow the string to vibrate at a fundamental 3 times as great? Right? So, can you do this in your head? I think you could do it in your head. If the frequency that you're talking about, okay, the 1045 is when it's 0.9 meters. Where do I put my finger in order to make it 3 times higher? Well, 3 times higher would be a third harmonic. 3 times the fundamental. Well, so if it's 3 times higher, what about the string? Say it out loud, say it out loud, say it to yourself. Some of you are not saying it. It's going to be 3 times shorter. 3 times higher would be 3 times shorter. So 3 times shorter than 0.9 is going to be 0.3. Now, I certainly could have done the math, but that you could do in your head. I hope you could do that in your head. Okay? So number 12. Aaron blows across the opening of a partially filled 20 centimeter high soft drink bottle. I don't know if you've ever done this. Have you ever blown into a bottle and got a pitch? Finds that the air vibrates with a fundamental frequency of 472 hertz. How high is the liquid in the bottle? Right, so this is the same. This is the same. So we're going to say that you've got L, which is the length of the height of the bottle. Because remember, this is not a string that's vibrating now. It's the air above the liquid that's vibrating. So there might be something that we have to do, because we're not measuring the liquid. We want to measure the air. So we know how tall the bottle is. Is that right? We know how tall the bottle is, and we would then find out how much air, what's the length of the air. So that's the L, okay? Well, we know that that is the number of antinodes, the number of hills, humps, times the speed of air, which we know, divided by, let's see, actually, it's slightly different. When we have a open-ended pipe, let's say an organ pipe that's open on both sides, your formula is going to be L equals NF over 2 frequency. Okay, that will also work with a string. So this would be an open pipe or a string. It's going to be a little bit different if one of the pipes is closed. So if you were to have a closed-end pipe and it's vibrating in the closed-end pipe, and we're going to see that if you were to splash in a swimming pool, sometimes right at the edge of the swimming pool, the water could go up or down like this, or it's possible that the edge of the swimming pool here, the whole thing can go up or down. So there's a little bit of a difference when you have an open pipe and a little bit of a difference when you have a closed pipe. Closed pipe is going to be 4F. Okay, we're going to say 4F. So that's slightly different. So I had to think of that. So let's plug and chug. We've got one of them, okay, because it's still going to be in the closed pipe. It's still going to be there. See, here's the water, and here's the edge of the bottle. So it's open at the top, but the water kind of closes that pipe. So this is going to be 1 times, and we know it's 340 normally. That's normal, divided by 4 times whatever the frequency is, 472. So it's going to be 340 divided by 4 times 472. Okay, so what is the height? That's going to be, this is the height of the water. Height of the water is going to be 0.18 meters. Well, we know that the whole bottle is 0.2 meters. So we have 0.2 minus 0.8 gives you the height of the air. So this is 2 centimeters high. That's the air above it. Okay. All right. And the last one is, no, that is the last one. Okay, we're done. Thank you.